All right, let us look at another question which is related to the proving of identities. We have to prove 1 plus secant theta minus tan theta divided by 1 plus secant theta plus tan theta equals 1 minus sin theta upon cos theta. So there are two important things that one must recall, and I have mentioned this in one of my earlier videos. Secant squared theta minus tan square theta is equal to 1 means secant theta minus tan theta times secant theta plus tan theta is equal to 1. This essentially means I can write secant theta minus tan theta as 1 upon secant theta plus tan theta, or secant theta plus tan theta can be written as the reciprocal of secant theta minus tan theta. Now, this form of expressing this identity proves very helpful in solving such questions. All right, let's get back to our question. We'll write down the left hand side, which is 1 plus secant theta minus tan theta over 1 plus secant theta plus tan theta. Now in some problems it becomes very evident just by looking at the right hand side what technique needs to be applied. It is not so evident in this question. So what we need to target is we need to look at the secant minus tan part of the numerator and try to convert it into this product so that we can get 1. And how would we do that? We need to multiply this part of the numerator with secant theta plus tan theta, its conjugate. And therefore we'll get secant squared minus tan square, and we can call that as 1. But you can't just multiply by this. You need to multiply the rationalizing factor with secant minus tan as well as with 1, and also with the denominator. So what we do is 1 plus secant theta minus tan theta, 1 plus secant theta plus tan theta multiplied by secant theta plus tan theta, secant theta plus tan theta. Now notice I'm going to multiply this term with 1, then this term with the second term. In the denominator though, I'm not going to multiply these two terms at all. I'm going to keep them just the way they are, and you will realize why I'm not multiplying them in just a couple of steps. So the numerator becomes secant theta plus tan theta as a consequence of multiplying 1 with this term, and the second term becomes secant squared theta minus tan squared theta as a consequence of this being multiplied by this. This is a minus b into a plus b, so you get a square minus b squared, and we're going to make this as 1. Denominator becomes 1 plus secant theta plus tan theta whole multiplied by secant theta plus tan theta. Now you would notice what happens to the numerator. This whole thing becomes 1, and we end up with 1 plus secant theta plus tan theta, which happens to be this factor in the denominator. So we can cancel this term with the entire numerator, which we're going to do right now. So this is secant theta plus tan theta plus 1 divided by 1 plus secant theta plus tan theta multiplied by secant theta plus tan theta. So I can cancel these two terms. That leaves me with 1 upon secant theta plus tan theta. Now remember, I can always write 1 by secant theta plus tan theta as secant theta minus tan theta. So I'm going to do that. So I'm going to write this as secant theta minus tan theta. Now if you observe what the right hand side is requiring, it is 1 upon cos theta minus sin theta by cos theta. So if I split this part is secant theta and this part is tan theta, which is exactly what we are having right here. So I'm going to write secant theta as 1 upon cos theta and tan as sin theta over cos theta, which ultimately becomes 1 minus sine theta upon cos theta, the right hand side of the equation. Therefore, we declare, hence prove.